In this video, we're going to be looking at the BFS algorithm for graph traversal. So we're going to start with our starting node as s equals 1. Here's our pseudocode, so we're going to be following the pseudocode. Press s equals 1. So we're going to be calling BFS on this graph g and parameter 1. So we're going to have a q and this variable v, which we're going to be keeping track of, and it's going to be kind of moving us around. And then I'll just keep track of the order here, right? So this is the order that we are visiting the nodes in. So to begin, basically, I'm going to write down the order that we label them as visited. So the first thing to do is to put the node 1 into the queue, just following the code here. Mark S as visited. Mark that starting node as visited. So there we go. This is now visited, and our first node visited is the node number 1. And then we're going to be stuck in this while loop for the rest of the algorithm. So while q is not empty, dq, so there's the head, we're going to dq that. So it's going to be a 1 here now in v. And we just ask for all the neighbors of 1, are any of them not visited? If so, put them in the queue and mark them as visited. So yeah, neighbors of v, yeah, there are a couple neighbors that have not been visited. 2, so I'm going to put 2 in the queue, mark it as visited. I'm going to put a 2 up here just to keep track. And 3 as well, right? So I'm going to put 3 in the queue, and I'm going to mark that as visited, and I'm going to put a 3, right? Okay. Next, we want to DQ once again, right? We're at the end of this for loop here. So we need to go back up to the while loop, and we're going to DQ. So the 1 is gone. We're going to take the 2 down. We're going to put it here. Let's move the 3 over. So now, once again, we just ask, for all the neighbors of 2, are there any that we haven't visited? And there are. So there's 4. So I'm going to put 4 in the queue. And I'm going to visit 4. And so I'm going to put in this list here. And then 5 as well, right? So 5 gets in the queue. 5 is visited. So we put 5 here. We're at the end of the for loop. There's no other neighbors of 2 that haven't been visited. We go back up here. And we DQ. So this is going to be a 3 now. That's going to get kicked out. And we ask the same question again with 3, right? We say, okay, so are there any neighbors of 3 that haven't been visited? And there certainly are. So 7. So we're going to go, we're going to do the better order. We're going to put 7 in the queue first. Then we're going to mark 7 as visited 7. And same thing with 8, right? 8 has not been visited, and it's a neighbor of 3. So we're going to put 8 in the queue, and we're going to visit 8. I'm going to mark that as visited here too. Okay, and we just go back up in the while loop, right? So we now, once again, DQ. So we're going to DQ 4. So 4 is going to go into our v variable. It's going to get kicked out of there. We just ask ourselves again, looking at 4, are there any nodes adjacent or neighboring to 4 that have not been visited? No. All the nodes that are neighboring to 4 have been visited. So immediately we just DQ. 5 goes in there. Are there any nodes neighboring to 5 that haven't been visited? Yes, 6, right? So we're going to put 6 in the queue, and then we're going to mark 6 as visited. So 6 goes here. We've now visited everything, so you could stop now if you want, but just to terminate the algorithm, it would go, 5 would be kicked out, 7 would be DQ'd, 7, every node neighboring 7 has been visited, DQ'd, 8, every node neighboring 8 has been visited, DQ'd, 6, every node neighboring 6 has been visited. And so now finally, we leave this if statement, and the while loop, the condition is q is not empty. Q is now empty, so we terminate the algorithm. And let's just look at quickly, like, what's the order we found all this stuff in, right? So the first node found was 1, because that's our starting. The next 2 were 2 and 3. And notice that 2 and 3 are a distance of 1 away. So it's like the next layer. It's layer 1, we call it. So this is L1. This starts with L0, layer 0. L1. L1 is a distance of 1 away. 1 hop, 1 edge. So maybe I'll just highlight as we go along. So that's layer 1, layer 2, sorry, I said the wrong thing. Layer 0, layer 1. Layer 2 is a distance of 2 away from the starting node. So I'll use green for this, right? So that was 4, 5, 7, and 8. 4, 5, 7, and 8 are all a distance of 2 away. And so they are layer 2. They are layer 2. And layer 3 is just going to be our final node here, because this node is a distance of 3 away from the starting node. So I'll just put that in whatever, red. blood red. And that is our L3. And so the way BFS works is it's about layers. You search in terms of layers. You don't mix up the layers. You search everything that's a distance of 0 away, which is just the starting node. You search everything that's a distance of 1 away, a distance of 2 away, a distance of 3 away, until you've visited everything. And that's the order that you visit stuff in for BFS. Okay, that is all for now.